The Venn diagram shows the sets P and Q contained in the universal set. List the members of set P. Now here we have set P represented by this circle, all right? And all of the elements that are inside of this big circle are the elements inside of P. And so you have A, E, F, D, and B. Now you may say, well, the elements B and D are elements inside Q. But notice that all of the elements that are inside Q are also inside of P because P is the bigger circle. What we have is a situation where we have Q is a subset, set Q, the smaller circle, is a subset of set P, which means that all of the elements that are inside of Q are also elements of P. And so that means that A, E, F, B, and D, especially B and D, even though B and D are elements of Q, they are also elements of P as well, right? Because they're inside of this big circle. So everything that is inside of this big circle, all of the elements inside of this big circle are members of P. And so it's gonna be A, E, F, B, and D. Those are the elements of set P. The next question says that we want the intersection between set P and set Q. So let's list out the elements inside set P. It's going to be A, E, F, B, and D, which we saw previously. Again, A, E, F, B, and D. Now let's list off the elements of set Q. Set Q, which is the smaller set right now, only contains two elements, which are B and D. So the two elements here for set Q are B and D. But we want the intersection of P and Q. And the intersection is going to be all of the common elements, the elements that are in both P and Q, which is going to be B, right? B is one, and D is the other. And so the elements of set P intersect Q, the elements of the set P intersect Q are B and D. All right, so these are the elements B and D. And that's the answer for this one. Next, the question says that we want to list the members of the set Q complement. Now, when we say Q complement, we mean that we want all of the elements in the universal set except for the elements that are inside Q. So we do not include these elements that are inside set Q. You do not include them, right? So we do not include B and we do not include D, but we include all of the other elements that are inside the universal set. So A, E, F, C, and G, they are part of Q complement. So A, E, F, C, and G, these are all the elements that are inside the universal set, but these we do not include the elements that are inside set Q. Next, the question says that we want to write down the value of the number of elements in P union Q. Now, when we say P union Q, we mean all of the elements that are in set P and Q combined with no repeat. So it's going to be A, E, F, and B and D. These are the elements of P union Q. But they want the number of elements. So let's count. It's going to be 1, 2, 3, 4, and 5. So there are 5 elements in P union Q. So that's the number of elements in P union Q. The next question says that we want to write down the value of the number of elements in P intersect Q complement. What are the elements of P? Well, the elements of P are A, E, F, B, and D, right? That's what we saw earlier, A, E, F, B, and D. What are the elements of Q complement? Well, Q complement means that we do not include any of the elements that are in this set. So we do not include any elements in set Q, right? We do not include them. And so that means that what we have for Q complement, A, E, F, C, and G. And that's what we have here, A, E, F, C, and G. But here they want the intersection, right? They want the intersection of these two sets. And the intersection of these two sets is going to be A, it's going to be E, it's going to be F, right? And so those are the 3 elements that are in the intersection of P intersect Q complement. And so they want us to write down the value or the number of elements inside this intersection. It's only 3 of those elements. And so the number of elements in P intersect Q complement is going to be 3. And so the correct answer here is 3.